Hello, hello. Is my voice is clear? Once tell me. Hello. Hello. Hello, hello.
Hello.
Yeah. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. So it's exam season. I hope that all of your exams are going very good. And we are here back with the marathon revision of class 11th. Yes, we are going to, for today's section, we are going to cover, you are going to start from the complete basics of units and dimensions. Then we are going to see kinematics, and then we are going to see the laws of motion along with friction. This much of the things that we are going to cover in this section. So are you excited? A complete marathon revision will be there. All the important aspects of the concept we are going to discuss in a quick time. Okay, so without wasting further any time, we are going to start. So be ready with your pen and paper. A lot of questions will be there for you to solve also. So be ready with your pen and paper, and let's start the marathon revision of class 11th now. Okay, so see here, we start from units and dimensions. Now you know about units and dimensions very well. Okay, I'm not entering into the basics, what are physical quantities and these kind of things. When we do the first time we enter into physical quantities, numerical value and unit makes it a physical quantity. So you know how to tackle those basic definitions. Okay, we will be coming to the questions from where actually questions comes. So the questions will be majorly coming from the quantities, fundamental quantities. So if you know the basics that what are the 7 fundamental quantities that we always use in physics, there are 7 fundamental quantities that are explained, and after that rest of the quantities are the called as derived quantity. That these quantities are derived from the 7 fundamental quantities. These 7 fundamental quantities are the core of physics. All the quantities that we define are originated from these 7 fundamental quantities. So if we will talk about what are those 7 fundamental quantities, it is length, mass, time, luminous intensity, candela, amount of substance, that is mole, that you study in chemistry, temperature and current. Now what are the representations, that also we'll see. What are the representation, that is also important, because in question solving the representations will be useful. So if I will tell you, representation for length is what? Length is represented as L, mass is represented as M, time is represented as T. This is not a lot used, but if it have to be represented, it will be represented by CD. Mole, it is represented as MOL. Temperature is not represented T, please remember, it is represented as K. And current, either a lot of places it have two representation, either a lot of places it is represented by I, that is also correct, as well as also it is represented as A. I'm representing ampere, so that is also fine. These are the two basic representations that you will be having for current. Now sir, then if these are the 7 fundamental quantities, then how I can define acceleration, velocity, force? There are number of quantities that are available there. So how we derive, and those quantities are called as what? Derived quantities. Derived from where? Derived from these 7 fundamental quantities. For example, let's suppose if you want to write the dimension for, let's suppose, acceleration. So what is the formula of acceleration? Acceleration is equals to meter per second square. What it is? Meter per second square. Meter means what? Meter is represented as L, length, and per second square, that means I can say it is divided by T square. So how will be representing the dimensions? It will be LT minus 2. This is the way how you write it. Is it fundamental quantities, when you represent it, never write it in denominator. This much of basic things you would be knowing about it. Okay, let's suppose you want to represent force. Okay, anyway, some basic fundamental quantities you should be naming directly, like for force you should be remembering, for energy you should be remembering, all these fundamental quantities you should be remembering. But apart from that, if you have to write, let's suppose, force, I will be writing mass into acceleration. Mass represented as M, acceleration represented as LT minus 2. Acceleration will be represented as LT minus 2. So what is the fundamental quantity of force mlt minus 2. Let's suppose you have to write energy. Energy, how will be writing? We should know only the formula. What is the formula of energy? Any general energy you can take, like half mv square mgh, the potential energy. From any formula you can derive. Pressure, how will be defining pressure? I know that force is what? mlt minus 2 divided by area. Area is what? L square. So just divide these two fundamental quantities, you will automatically having your pressure. Okay. Two very important things, that plane angle and solid angle, they are actually dimensionless quantity. They will have units, but they are what? Dimensionless quantity. That is very important. These two quantities are very important. Directly it have been asked in the previous years as well. Okay. Now let's move further. Some prefixes that you should be remembering, at least from this much. 10 power minus 15, 10 power minus 15 is called as femtometer. Picometer, 10 power minus of 2 nanometer, a lot of in our use. Even angstrom also you should be knowing about. Mostly we use in chemistry, 10 power minus of 10. Micro, 10 power minus 6, milli, 10 power minus 3 centi. These many at least you should be remembering, because it is very often that is have been used in physics. Okay, so these are the basics of physics. See, let's suppose you have to write the dimensions of these many quantities. How will be doing? Force, already I have told you. Let's suppose you want to write the dimension of pressure. How will be writing? For writing any kind of dimension, understand it. What is pressure? That you know, it is nothing but force divided by area. What is force? Force is nothing but mlt minus 2 divided by area, that is L square. So how you will be writing it? It will be ml minus 1 t minus 2. Correct? Pressure will be ml minus 1 t minus 2. Then what you will be doing? This third option is work done. You have to write. How will be writing work done? What is the formula that you know about work? Formula should be remembered. Otherwise, if you don't know the formulas, how will be writing the dimensions? Formula work done can be written as force into displacement. F dot ds you can write. Force is what? mlt minus 2, and ds is what? L. Because what is change in this position? ds is what? Displacement. So displacement is also a quantity of length, simply I can say. So here what will be saying? It will be net become ml square t minus 2. This way you can write momentum. If you have to write momentum, कैसे लिखोगे momentum? Momentum is equals to mass into velocity. Correct? Wait a second. So how will be writing momentum? Momentum will be written as mass into velocity. Mass is represented as m and velocity is represented as lt minus 1. Correct? So you understand how to write dimensions. Now dimensional analysis. What are the basic uses of dimensional analysis? Majorly we have three varieties of questions in dimensional analysis. So let's see one by one what kind of questions we used to get. Okay. First one is often to check the formulas. What is the first dimensional analysis? We say that if any formula is getting added up or subtracted, that means number of terms, whatever the number of terms are present, all those terms should have a same dimension. This is the very first rule of dimensional analysis. Let's see here. What are the uses? Checking the correctness of the given physical relation, whatever I've told you, whatever the formula or the relation that will be given, you have to check that whether it is correct also or not. Dimensionally checking. It is not mandatory that if any relation is dimensionally correct, it will be physically correct also. I will proving that also. Let's come to that after some time. Second will be conversion of units. You can convert the, like if you want to convert dyne to force, how you will be doing? There is a concept of n1 u1 is equals to n2 u2. What is n1? N1 is what? The numerical value. And u1 is what? If u1 is what about the units. So this way you would be idea about that kind of questions also. Then deducing a relation among the physical quantities. Then you have to create, let's suppose any random quantity is given x, and it will be given into the question that this random quantity x is related with directly proportional to some x power a, y power b, and some z power c. This kind of some relations are given. So you have to deduce a relation from there. Okay. So let's start from the first. Check the correctness of the given physical relation. How to check it? Now understand here. Better you will understand from a question. Okay. See, for example, I am giving you a scenario. Very basic relation I am giving you. For example, S is equals to ut plus half at square. In this only everything will be checked. Now what I've told you, you have to check that we know that this is physically correct, and we know that we are going to prove that also correct. But I will be, what is the motto of this question? Understand. Firstly, prove that it is dimensionally correct. How will you proving? I've told you that if any quantity, all the terms in a relation should be of the same dimensions. You know about terms. Terms are separated by plus either from minus. Tell me, what is the dimensions? Start telling me the dimension. What is the dimension of S? S is represented for displacement, that means it will be represented as L. Then UT. UT will be represented as what? LT minus 1 into T. LT minus 1 into T, that means it will net effectively, it will again become L. So here also L, here also L. Till now we are fine. Now this is one more term. For this, what will be the dimension? Let's check. Half constant doesn't have any dimension. Acceleration. What is the dimension of acceleration? LT minus 2 into T square. Into T square. Can I say T square and T minus 2 will be cancelled out and remaining part will only be L. So can I say S is also L, UT is also L, and half AT square is also what? L. Half AT square is also L. So can you say it is dimension correct? Yes, I can say it is dimension correct because all the terms that are coming here is L. Correct. So I can say that in the answer that sir, it is dimensionally correct. But now what is the plot? One more thing here that you have to understand. What if I will give you the same relation, but let's suppose I have given you a relation S is equals to UT plus AT square. S is equal to UT plus AT square. Now tell me, is it dimensionally correct or not? Check. Again it will be L, again it will be L, again it will be L. All these three terms are L, L, L. All these three terms are L, L, L. So I can say that it is dimensionally correct, but it is not physically correct. Because that is one more the limitations of dimensional analysis. That dimensional analysis will never give you the idea about the constants. Dimensional analysis will never give you the idea about the constant. Remember this one thing. So if any formula is dimensionally correct, maybe in multiple choice questions, the question will be coming that a given formula is dimensionally correct. So whether it is possible that it is always physically correct also? No. Here is the example. This formula is dimensionally correct, but it is not physically correct. Clear? Fine. Now see. Here it is a question. Let's understand from the questions. We'll have much better idea because we are in the revision. So I hope that basic theory I don't have to explain. The more questions we'll do, the more understanding we will get. Now see here. What is the question? Find the dimensional formula for A, B, C in the equation. Our equation is given y is equals to A sine bt minus of cx, where y is the displacement, t is the time. Now again write the equation. What is the equation? Y is equals to A sine of bt minus of cx. Now a property that I am going to tell you, the second important property was first important property. I have told you what, that all the terms that are present in a formula should be all should be having the same dimensions. Now the second one, terms like sin x, cos x, tan x, sin inverse x, cos inverse x or tan inverse x, log x, e to power x, all these terms are dimensionless. All these terms are what? Dimensionless. And if all these terms are dimensionless, I can say that the x that is connected there, sin of x, that means that x will also be dimensionless. This is the second rule that you have to remember for solving purpose of the questions. A lot of questions can become on this application, and this question is on the same application. Now understand what is the how you'll be solving. What I've told you, this is given as displacement. Now understand what I've told you, that sin of x is what? Completely dimensionless quantity. That means can I say that this complete term that is given is dimensionless, and this formula is correct? That means I can say the dimension of LHS should be, it is mandatory to be equal to the dimension of RHS, correct? So I can say this complete is dimensionless. That means can I say the dimension of y have to be equal to the dimension of A? Yes or no? Yes or no? So I can say that dimension of A I got that is equal to dimension of y, and dimension of y is nothing but equals to L. First answer. Correct? First answer I got, that it is equals to A. Now come to the next question. What is the next one? Now calculate. Now come to the dimension of B. How we can calculate the dimension of B? What I've told you, that if sin of x is a dimensionless quantity, x is also a dimensionless quantity. That means this complete inside term is a dimensionless quantity. If this complete inside term is a dimensionless quantity, that means I can say this bt is also dimensionless, and this Cx is also dimensionless, correct? If this Cx, that means I can say this B into T have to be dimensionless. For making it dimensionless, can I say B have to be equal to 1 by T? Yes or no? Yes or no? If B will be equal to 1 by T, that means this T will be cancelled. Again, it will become dimensionless quantity. Correct? That means what is the dimension of B that I am getting? It is equals to 1 by T. Same way you can say for the dimension of C. What will be saying about the dimension of C? That multiplication of C and X should be dimensionless. For making it dimensionless, I can say C is equals to 1 by. Here you can also say that M0, L0, T0, that is equals to, again becomes to 1, and here it will be equals to 1 by X. So these are the dimensions that you are going to get from this question. So question is one, but the concept that is important to understand, it is a lot. Okay, a lot of questions also comes from this topic. Easy topic, but yet scoring. At least one question you will always be having from this topic. Okay, fine. Now, how to establish a relation between different physical quantities? Now, the third variety of questions that you will be facing here. See how you can find the relations. See, read the question. I will be explaining everything in the question itself. The centripetal force F acting on a particle moving uniformly in a circle may depend upon mass. See, what is the question? A force is given. A force is given. And what is given the details about that force? That force acting on a particle moving in uniform circular may depend upon the mass. That means force is depending upon the mass. That means force is directly proportional to mass. I don't know how it is depending, but I will say that, okay, let's suppose that it is dependent and it is proportional to 1. Force is directly proportional to m power a. What other else I will say? That it is directly proportional to velocity power b. And radius of the circle, and it is also proportional to the radius of the circle, that is c. It is also proportional to the radius of the circle. So I can say force is proportional to these three quantities, correct? And rest of the values, you have to calculate what is the exact formula for the, from these four options that are given, you have to calculate the correct formula. How will we doing this? Now see, what is the method? You have to write it collectively. Combine all these three things and write it. Can I say force? I can write that is equals to some constant k that will be due to proportionality, and m power a, v power b, and r power c. M power a, v power b, and r power c. Then what you will be doing? Just write the dimensions properly. What is the dimension for force? M L T minus 2. Just now we have seen k, m power a, L T minus 1 power b, and a radius that is equals to L power c. After that, I will further segregate it. K. Tell me what is the net power of m on the right hand side. Net power of m, can I say it is nothing but equals to a only. L. What I can say about the net power of L? This is also L. So I can say it is b plus c. And what I can say about the power of t? T, I can say it is equals to minus of b. Correct? And at the LHS side, what are the values that I have? I have m L T minus 2. Now compare the RHS and the LHS. When you compare the RHS and the LHS, I can say m power a. That means a is equals to 1. Can I say? Because mass here, what is the power? 1. And on the right hand side, what is the power? Power is equals to a. Hi Sujal. So I can say a is equals to 1 simply by equating the powers. Then the second one. What I can say about length? Length, I can say on the LHS side, the power of length is equals to 1. On the RHS side, what is the power? It is equals to b plus c. Okay. Now, what about time? Time, I can say here on the LHS side, what is the power of time? Time is equals to minus 2. On the RHS side, what is the power? Power is equals to minus of b. Correct? That is what I can say from here, that b is equals to 2. B is equals to 2. If b is equals to 2, what I can say about c? C can be written as 1 minus of 2 going here. That means it will be minus of 1. C will be equals to minus of 1. All these three values are we got. Now just put the values here in the final equation. What I have written? Force is equals to k times of mass power a. Mass power a, that is equals to 1. V, that is power 2, and divide by r. R is minus 1. That means I will write mv square by r, and we know that centripetal force is nothing but equals to mv square by r. This is a basic thing that we already know. Correct? Is it clear? So it was correct, and of course I have told you that it is not going to give you any idea about the constants. So this k value will be random. Okay, it is not going to give you the exact idea. Anyways, you know that centripetal force is mv square by r directly. That means k is also going to be 1. But still, in a lot of formulas, like if you are solving the questions of those questions of units and dimensions of time period, so if you are solving those questions, you will have only the relation of root under L by G. It will not give you the idea about the 2 pi, because the formula for time period is what 2 pi root under L by G. But dimension analysis will never going to tell you about the 2 pi. Okay, so this is the limitations of dimensional analysis. Correct? These are the limitations that are written here. I've already told you that it is not going to give you the value of L. So these are the some important things that you have to understand. Now the next very small topic that is present in units and dimensions, and that I will say is also very important, that is the counting of significant digits. How many number of significant digits are present, how to calculate. There are some certain rules, some very basic rules are present that you have to understand, and from there you can calculate the significant digits. Let's understand one by one rule, and for some examples are also given. Okay, some examples are also given, so you can take those examples as well. Suhas sir is trying to come making raid in our class. So he is enjoying his tea. Hi sir.
The same topic I already discussed with the student. Significant figures.
You have discussed significant digits.
Exactly.
In chemistry also, students, significant digits are there. I didn't knew actually, yeah.
Sir, in some basic concepts of chemistry, significant figure is there.
Sir, why you look so dark in the frame of the camera?
Sir, you are handsome. I am not handsome. That's
Thank
the
you.
thing.
Thank you, sir.
Okay, sir. Continue.
Okay.
Shaipi.
I have taken, sir. I have taken.
Okay. All the best, guys.
Okay. Let's continue from here. Some basic rules are there that one by one, let's see, you will be understanding, and if you have a very good luck in the exam, maybe you will have a questions from significant digits, who knows. So why to skip this kind of easy chapters? Just a 5-minute thing can give you +4 marks, then there is no point of skipping the topic. Correct? Let's see. First rule, all the non-zero digits are significant. That means all the non-zero digits, that means other than 0, all the numbers that will be present will be all be counted as significant. For example, in this example, if you will be taking 42.3 to 43.4, that means how many significant digits are there? I can simply say 3 significant digits. In this one example, what I can say, how many significant digits are present? 1, 2, 3, 4. 4 significant digits are present. Here what I can say, here 5 significant digits are present. Correct? So this is the one thing that I can say. Okay. Next thing, all zeros become significant if they appear between two non-zero digits. If you are applying 0, okay, there is condition for 0. It is not like that always it will be calculated insignificant. It will become significant if you are adding the zeros in between two non-zero digits. For example, let's suppose you are having, here only the examples are, let's suppose the number is 5.03. 5.03. That means here I can say 0 is coming, but 0 is coming between two non-zero digits. That means I will count this 0 as a significant figure. That means how many significant digits are present here, students? Here 1, 2, 3. 503, all three are significant. Next example, 5604. That means how many significant digits are there? 4. Here see, again 0 is coming, but this 0 is in between two non-zero digits. That means I can say 4 significant digits are present here. 4004. All 4 will be the number of significant digits. Correct? Next one, leading zeros or the zeros placed to the left of the first non-zero digits are insignificant. Leading zeros or the zeros placed to the left of the first non-zero digits are insignificant. If you have applied that 0 in the front only, in the leading place only, then it will be calculated as insignificant. Obviously, let's suppose I will ask you to write 100. Okay, let's suppose I will ask you to write 100. So what you will be writing? You will be writing, sir, 100. What if I will apply a 0 in front? Nothing is going to be changed. Again apply one more 0 in front, again nothing is going to be changed. So this is the case. Okay, so if you are applying, for example, here it is written 0.543. now it's your choice, apply how many number of zeros you will be you want to apply, but the number of significant digits will only be 3. Next case, how many number of significant digits you will be having? Only 2. Here, how many number of significant digits you will be having? Only 1. So the zeros that you are applying before at the leading place, it will be calculated as insignificant. Correct? Come to the next one. 0 placed to the right of the number after a decimal places are significant. Zeros placed to the right of the number after a decimal place. After a decimal place, if a zero is placed, then it will be calculated as significant. You cannot make it insignificant. Important is what? Zero at the end and after decimal. These 2-3 things that you have to always keep in mind. Otherwise, you will be only getting confused. So here, if I will ask you how many number of significant digits are present, I can simply say, sir, 1, 2, 3, 4. 4 significant digits are present. Okay. Let's next move to the next one. Exponential notation, the numerical part gives the number of significant digits. See, in exponential portions, you have the exponent part that is present here. Let's suppose in this example, if I will say 1.32 into 10 power minus of 2. So this 10 power of minus 2 is insignificant. We didn't consider it as a significant figure. What is the significant figure that is present? It is equals to 1.32. Only number of significant digits, if you have to quote, it will have only 3 significant digits. Is it clear? Same example here, how many significant digits are present? 4 significant digits are present that you can easily consider. So let's suppose now you are adding two numbers and you have to quote your answer, that how the answers will be quoted. So there are some certain rules for that also. For addition and subtraction, same rule. For multiplication and division, same rule. So let's understand the rules. What is the rule is saying? If it is an n values, and I am directly telling you, you just have to check the number of significant digits after the decimal. After the decimal. Number of significant digits after the decimal should only be n. Let's suppose here, tell me what is the number of significant digits. I can say after the decimal place 1. Here number of significant digits after the decimal, it is 2. Here number of significant digits will be taken as 3. So you will only quote the number of significant digits that are least. Tell me which is the least significant digits after the decimal. That is equals to 1. That is equals to 1. That means your answer will also have only one significant digits after the decimal. That means after solving this, whatever the long answer you will be having after the decimal, but how you will be quoting your answer, you will be quoting that least significant digits is 1, and you can make it n also, but that is not of our use. You should be enough smart now that you can make it. So what you will be quoting as answer, this n is equals to, the least value is equals to 1. So answer should also have only n is equals to 1. Check here, what is the number of significant digits after the decimal place? Only 1. Correct. This is the rule for addition and subtraction. Now let the case of multiplication or division. Multiplication and division also has same kind of rule. Now understand, the final result should retain as many significant as there are in the original number with the least significant figures. Now see, let's suppose you are doing a division. Here the example is given for division. Tell me what is the number of significant digits. Here you have in the numerator, here you have 1, 2, 3, 4. 4 significant digits. And here in the denominator, how many significant digits you have? You have 3 significant digits. So what is the least significant digits? Least significant digits is 3. This time we don't consider only the decimal places. Here we consider the complete number. So your result, so your final result will also have only 3 significant digits. So the final result will also have 3 significant digits, that is equals to 1.69. Correct? Now let's enter into the error part. Error part is also connected and it is also a very easy kind of topic. So let's understand error part also. You know the basic types of errors. One is systematic error, one is random errors. Okay, those are connected with the different scenarios. Systematic error, now understand what is systematic error. That tend to be one direction, either positive or negative. So it is due to the measuring instrument. Systematic errors, let's suppose you are having a scale and your scale is broken. So always when you will be calculating, there will be some error in the calculation because you have broken, you are using a broken scale. So due to the measuring instrument, the error that used to come, that is called as systematic error. Random errors are due to the I can say due to surrounding problems. Let's suppose a very heavy air is going on. Some temperature problem is there. So due to those kind of things that you cannot avoid, those kind of errors are come under random errors. Okay, these are the two basics of errors. So what kind of questions can be asked? Questions can be asked either they will asking you absolute error, or not a lot it is asked about absolute error. The major questions will be asked. Once in NEET exam it was asked for mean absolute error, how to calculate mean absolute error, relative of fractional error, and then percentage error. Fractional error and percentage error are a lot relatable because just multiply 100 into the fractional error, it will become a percentage error. So these three are the major kind of errors that you have to understand. Let's see. See, first one, mean absolute error. All the errors are measured here. Let's suppose you have did a measurement, like you have calculated a length a lot of times, and you have this much of observations, a1, a2, a3 and till an. Okay, firstly you will be calculating the mean. How you calculate the mean? Mean is nothing but the average, sum of the observations divided by the number of observations you have calculated your mean. Now you will calculate the absolute error from the mean value. I will be calculating absolute error. Just subtract all those observations one by one from the mean value. This is your mean value. Subtract a1, then subtract a2, then subtract a3, then subtract an. Okay, so that way you will be having the values delta ai. You will be having the value delta a. For example, if I have to say, if I have to calculate delta ai1, I will be calculating am minus of a1. If I have to calculate delta a2, I will be calculating mean that I have calculated minus of observation 2. If I have to calculate delta a3, I will be calculating it by subtracting from the mean error minus of a3. I will be calculating delta a3. If I have to calculate mean absolute error, now take the sum, make the sum of all these absolute errors divided by the number of errors. That's it. That is what mean absolute error. So this is the step. What firstly you will do? Firstly you will be taking the average of all those values. Then you will be calculating the absolute error one by one. Then what you will be doing? Mean absolute error. Just take the average of all those absolute error that you have calculated. That's it. That is the basic process that you have to follow. Is it clear? Relative error. Mean absolute error divided by the mean value. This is the formula for relative error. Percentage error, delta, that means the fractional error that you will be having. Its relative error or fractional error is expressed in the percentage. Delta am, that is the absolute error divided by the mean average that you have calculated multiplied by 100. For fractional error, more specific formulas are present. Hi Abhirish. So let's understand here in better way when you will have a numerical values, how to calculate the errors. Percentage error, let's suppose the question is asking you, one value is given as 20 plus minus root 2 and second value is given as 3 plus minus 0.6. So how you will be calculating the percentage error? See, percentage error is what? Delta x by x. This is what? A fractional error. This is called as what? Fractional error. And then multiply the 100. Then multiply 100 with it. That will be called as what? Percentage error. Now see how to represent this number. This is the absolute value and this is the error part. This after this plus minus the value that is written, that is what the error part. So how I will be writing delta x, what is the error part? Delta x is for error, is 2 divided by what is the absolute value? This is in terms of x plus minus of delta x. I will be writing the error part. Error part is nothing but 2 divided by x value is 20 into 100. Into 100. Now what is the value that is going to come? This will become 5. I can say 10%. So this value can also be written as x, that is 20 plus minus 10% of error is related with it. This is the meaning that you will be having. Sir, will you take probability? Beta, I will not take probability. Probability is the topic of maths. So maths, sir, will be, of course, will be taking probability. Okay, here we are talking about physics. Firstly, we are talking about units and dimensions. Then we'll be talking about kinematics. A quick revision kind of session this is, and then we'll be moving to the laws of motion. We'll be understanding how to write the equations. Okay, we'll be understanding how to write the equations of motion. Okay, so if you want, I will tell to our math sir. He will be probably of course taking the probability session as well. Okay, in physics, if any topic you want, then tell me, I will be arranging that. Clear? So let's take one more example. Let's suppose it is given as 3 plus minus 0.6. What I've told you, this is the absolute value and this is what? The error portion. If you have to calculate percentage error, how will be calculating the percentage error? Percentage error will be 0.6 divided by the absolute value, that is 3 into 100. Correct? Now just solve it. It will be 0.2. That means answer will be 20%. That is the error that will be connected with this value. Okay. Now see, let's suppose you are adding or subtracting. One very important thing always keep in mind, errors never get subtracted. Better, you will be making mistake, I know. This is the major portion where the students will always make mistakes. Errors never get subtracted, never ever. Okay, see, let's suppose you are having x plus 2y. Just calculate the value part normally. For example, if I will take the first example, let's suppose this one, x is given as what, 30.6 plus minus 0.01, and y is given as 15.1 plus minus 0.04. What I've told you that this is the absolute part, absolute numerical value, and this is the error portion. Here this is the absolute part, and here it is the numerical portion. Correct? Now how will be writing this portion? See, what you'll be doing, firstly calculate the absolute part, that is x plus or times of 2y. Then means you will be writing 30.6 multiplied by 2 times of 15.1. Check करो कितना value आएगा. 30.6 will be as it is, and multiplication of 2 times it will give you 30.2. Correct? 30.2, and you will be writing the as it is portion. Now how you will be writing the errors? Errors you will be writing, x is one time multiplication, that means it will be 0.01 plus errors never get subtracted. I will tell you in the next example. Now multiply it 2 times, that means it will become 0.08 because it is 2y. That means you will be multiplying the error also 2 times, and just add it up. What will be the result finally? 0.0009. Finally the result that will be quoting like this. Separately calculate the normal portion, separately calculate the error portion. Correct? Next example is more interesting. Here it is the multiplication case. Still multiplication, sorry, not multiplication, subtraction case. I'm sorry, subtraction case. Normal value will get subtracted. Normal value will become how much? Again x minus 2y. That means here you will make 30.6 minus of 30.2. The result will becoming 0.4. But the error part will always get added up. Error part never gets subtracted. This have to be keeping in your mind. इसको तो just lock it in your mind that कभी भी गलती से भी never ever do error subtraction. Okay, this is a crime. I'm telling you, this is a crime that you will be doing. Now for multiplication and division, very simple formula to be there for errors, fractional error or percentage error. I have told you that if you are able to write the fractional error easily, you can write the percentage error. Let's suppose any equation is given as a by b, and if you are to write what is the fractional error in x, how will be writing it? You will be writing simply it as delta a by a plus of delta b by b. That's it. If you have to write for division also it is going for the same case. If it is the division case, again you will be writing the same thing, delta x by x is equals to delta a by a plus of delta b by b. That's it. And of course if it is an error, it can be plus or minus, so you will have been attaching it with plus or minus. Just simply remember this thing. Okay. Slight change will be coming when there will be exponentials. Again a basic question, again the same kind of solving you have to do. Firstly calculate for the absolute value. Let's suppose here it is what, x into y. That means what you will be doing, if you have to quote your final answer, here x is also given, here y is also given. Final answer that you will be quoting, it will be x into y, the absolute values, plus minus delta x plus of delta y. That's it. This will be your final answer, because errors always get added up. Check karo bhaiya. X into y, 20 into 10, that means it will become 200. And add up the errors. When you will be adding it is 0.01 plus of 0.02. That means final answer will be how much? 0.03. Sorry, fractional errors it is represented here. If you are adding the fractional errors, it will be delta x by x and delta x by y. Just put the x value here. X will be taken as 20 and y will be taken as 10. Fractional error in terms of if you are writing, just add up them, you will be having your final answer at 0.5. That's it. In division also it will be going the same. Absolute value just divided, 20 divided by 10, it will be 2, and the errors will be just adding up them. And I think so the value here is given as wrong. You will be calculating it. The errors will be calculated as delta x by x plus of delta y by y. Delta x is what? Delta x is the error part, that means 0.01 divided by x, that is equals to 20, plus of y term 0.02 divided by y, that is equals to 10. Correct? Here I guess the calculation mistake is there. You can calculate it from your own, a basic calculation. Clear? Now the exponent part, if you are having an exponent, then how will be writing the errors? See that, let's suppose this is kind of equation you are having. Division, that means you know how to write the fractional errors. If you have to write a fractional error, that is delta x by x, I will be writing that, you will be writing n times of delta a by a plus of m times of delta b by b. That's it. That will be the what? Fractional error will be. That will be fractional error. Is it clear? समझ में आया errors? Let's take an example. Basic question is there. Some values are missing here. Some values are missing. See how to solve this kind of question. Let's suppose I am framing my own question. Let's suppose here if it is a power 3, b power 2 and c power, let's suppose anything you can take. Let's suppose what will be taking 3 and d power, let's suppose 4. For example, this is the value of p. Let's suppose p is given as some value a power 3, b power 2, c power 3, d power 4. Let's suppose this is the question. And the percentage change are given. Percentage change are how much? This is given for a for given it is 1%, for b it is 2%, for c it is 3%, and for d it is 4%. These are the percentage change that are given for a, b, c, d. And the finally question is asking you, tell me the percentage change that will be coming in p. So how I'll be doing? Firstly, write the percentage change delta p by p. And now you will be saying, sir, multiplied by 100, but I will not do because 100 is common. If I am writing here also for a also, if I am writing the percentage error, I have to multiply it by 100. So all those 100 is eventually going to cut. So I will be simply writing the errors only. I will be writing delta p by p is equals to 3 times of delta a by a plus 2 times of delta b by b plus 3 times of delta c by c plus 4 times of delta d by d. That's it. That is my complete error. Simple, clear? Now come to the next portion, that is the new portion that we are going to understand is kinematics. Kinematics, yes. From here actually the physics got started when, if you remember your normal days when you have started kinematics fresh. Okay, you have taken a lot of time to understand kinematics. Basic understanding you got in the basic classes 9th, 10th only, but here we understand the upgraded version of kinematics. Like we go in 2 dimensions, we see the accelerations part, gravitation part. Here we see also the retardation case, graphical case. All these things we do here. Okay, so let's start kinematics now. It's time for kinematics. So let's see. For if you are starting kinematics, first basic 3 things you would be asking. Okay, let's suppose any body is moving. Let's suppose this remote is moving. What are the 3 questions I will ask? Basic 3 questions I will ask. What is the time? What is the position of this remote if it is moving? What is the time? At what time it is moving? Where it is moving? And with respect to whom I am watching? Who is the observer? Because frame of reference is the most important thing in kinematics. Whenever you have started, your teachers will be telling you a lot about a frame of reference. A very I will say dynamic statement is there that nothing is at rest and nothing is at absolute rest and nothing is at absolute motion. Complete game is about the frame of reference from where you are watching this motion or the rest. Okay, so if you are saying that, sir, I am moving in a bus, so I am in motion. I will also parallelly moving, and or maybe I will be sitting next to you. So I will say you are not moving, you are stationary. But if I am standing on the road, I can say that yes, you are moving. So I am the only person who was commenting. But one time I was in the bus and one time I was on the road. So I can say, let's suppose you would be saying, sir, I am sitting in my home at my bed. I am sitting. So how you can say that? Let's suppose you are also sitting. So how you can say that I am in a motion? So I will be saying, beta, I am watching you from different planet. Then you are sitting at that. I am watching you from different planet, and respect to that, you are moving. Again, you are in motion. You are feeling like that you are in absolute rest, and you are. But this complete game is about reference. So first, basic 3 questions what you will ask: at what time, where you are, and who is watching. These 3 are the basic important questions, and if you get the answer for all these 3 questions every single time, kinematics is done. Question these 3 things in every single question, kinematics is done. This is the soul of kinematics. So let's understand by different cases, different examples. Firstly, it will start from position, distance, and displacement. Distance, what you understand, the actual path that have been traversed is called as distance. And what is displacement? The shortest path, or the position vector. Also in terms of vectors, what we define, the position vector from the initial to final position, a straight line when you will be drawing, that will be called as displacement. Okay, basic definitions. I think that I don't have to enter that much in distance and displacement. Here, let's suppose I have to define the position vector. how you can define the position or displacement vector. See, there are two vectors, two positions are given, r1 vector, and here it is given as r2 vector. Positions are what? x1, y1, z1, and here positions are what? x2, y2, and z2. So I will be writing the r1 vector. R1 vector will be written as x1 I cap plus y1 j cap plus z1 k cap. I will be writing the r2 vector. It will be x2 I cap plus y2 j cap plus z2 k cap. These are the two position vectors that we will be saying. Now, if you have to write the position vector, how you will be writing? Position vector is nothing but this is the position vector, r vector. R vector is the position vector or the displacement vector between point P and Q. I will be writing this will be simply written as r2 minus of r1, r2 minus of r1. So I will be writing r2 vector. You already have x2i plus y2j plus of z2k. Just simply subtract. So what will be the final position vector you will be having? You will be having x2 minus x1i plus y2 minus y1 j plus z2 minus z1 k. Simply you can define the position vector. Correct. So if anything is rotating in circular way, then how will be writing the distance and displacement? See, let's suppose any particle is present there. In this motion, it is doing some kind of sort of circular motion, and it is going from point A to B via point D. So I can say this portion is called as what? It is called as arc. It is called as arc. So the distance, if I have to define, distance is defined as the length of arc. Distance is defined as length of arc. And how? What is the definition of length of arc? I will simply multiply the radius and with it theta. The angle that is subtended here, I will defining by that. This, let's suppose the angle subtended by this arc is theta, and I will multiply with the radius of the circular motion that you are having. That will be defining by the distance. This is the way how I define the, either you can say length of the arc in the one way, either you can say this net I am writing the distance. Correct. Next thing, displacement. If you have to write displacement, how you will be writing? Displacement is only watching at the initial and the final position and that directly connect a straight line. That means I can say this point A to be this red pen, the length that I have drawn, this is my displacement. So in this triangle, if you want to define, how you can do, this is r, it will have two components. This will be r cos theta, this will be r sin theta. Component lene aata hai, correct? So I can say this half distance is what? R sine of theta by 2, and this distance will be again r sine of theta by 2, and combined this will become how much? This will become 2r sine of theta by 2. Is it clear how to write distance and displacement even in the circular manner also? Let's suppose any arc, if it is making this kind of arc, then also you are able to write distance as well as displacement. Similar in rectilinear motion you can easily write, but in curvical motion a lot of times students have doubt. So I think that now it will be clear. Now come to the next parameter of motion, that is speed. In speed also, what is speed? Distance divided by time, unit meter per second. It is a scalar quantity. Velocity is a vector quantity. These kind of basic things, it would be clear to you. These are the things that are written here. Now it have different varieties based on time. There are two types. Based on time, you will have average speed, or either you will have instantaneous speed. Basis on distance, it will have uniform speed and non-uniform speed. Now these four things will be coming in everything, in velocity also, in acceleration also. So now understand at one time, and same kind of pattern will be repeated for everyone. First thing, average speed. Let's suppose you are traveling and you are going to, let's suppose, a distance that will be 100 km from your house, and you are moving with your vehicle. Okay. So what will happen? Somewhere the traffic lights will be there. Somewhere you will be stopping to purchase something. Let's suppose you are going to meet your girlfriend, then you are going to purchase a flower for her. It's a Valentine's Day, so you'll be purchasing flowers for her. You'll be stopping there. Then again you'll be starting. Again you'll be accelerating. Sometime you'll be moving at very high speed. Okay. Sometime you'll be moving at very high speed. Sometime you'll be getting slower. So all these things will be happening. So what is the sole purpose when I will be asking you, tell me your average speed? That means average speed counters the complete motion, complete 100 kilometer that you have traveled. I will be discussing about those complete 100 kilometer, that what is the average that you use with the speed. So maybe it will be nearly 40-50. So any value, let's assume the average that is coming after your complete motion is 45 kilometer. So what it tells me, that at an average you are taking 45. It's not that it is absolute that always you are moving at 45. It is an just assumption that somewhere you would be down to 30, somewhere you would have up to 60 also. But at the average, if I am calculating, it will be 45. That is the idea of average. Instantaneous is about instantaneous. From the name itself, it is very clear. Let's suppose if I'll ask, tell me at time is equals to 30 minutes. At 30 minutes, you was at what speed? It talks about the instantaneous moment. Okay, in which moment you are there, it talks about the moment. Okay, this is about instantaneous. Next thing is about uniform. Uniform speed means what? You are covering equal distance in equal interval of time. That is called as uniform. If you are covering equal distance in equal interval of time, it is called as uniform. Non-uniform, you are covering unequal distance in unequal interval of time. That is simple. Let's suppose in first 10 minutes you have covered 10 kilometer. In next 10 minutes again you have covered 10 kilometer. Next 10 minutes again you have covered 10 kilometer. Then that means what kind of motion you are performing? You are performing a uniform motion. And if you are in first 10 minutes you are covering 10 kilometer, in next 10 minutes you are covering 15 kilometer, in next 10 minutes you are covering 20 kilometer, that means you are accelerating, and it is called as non-uniform motion. Okay, it will be called as non-uniform speed. Okay, so these same kind of things will be coming in velocity as well and in the acceleration as well. Here it is an example of average speed. Average speed, now come to the formula. Average speed, the basic formula that we'll be having is total distance traveled, okay, divided by the total time taken in the complete motion. Here is the motion is represented, time value is given, and distance is also given. So if anyone asks you, tell me what is the total average velocity, you will be calculating by the total distance that have been covered divided by the total time that have been taken to cover this motion. Correct? Next one is instantaneous. Instantaneous, always remember, just differentiate the equation at the moment which it is asking, and just put the values. You will be having your instantaneous. You can say it is rate of change of distance. Correct? So ds by dt is going to give you the answer. Uniform speed, better example here. Uniform speed, understand, 0 to 50 seconds. In terms of seconds we are talking about. 0 to 50 seconds or 100 second one time interval is given here for 100 seconds. 0 to 100 seconds, how much distance is covered? 400. 100 to 200, how much distance is covered? 400 again. 200 to 300 again, and 100 seconds again 400. So I can say in uniform time you are traveling a uniform distance. That means I can say it is a uniform speed. Non-uniform, take the example. In 100 seconds you have covered 300 meter. In next 100 seconds you have covered 500 meter. In next 100 seconds it have covered 800 meter. So I can say it is going in non-uniform motion. Correct? So let's have a question and try to solve this question. What the question is saying. Okay. What the question is saying. A man travels from A to B. Diagram. In all these questions, first step will always be to draw the diagram. Diagrams are very important. It will make the questions very simpler for you. A man travels from point A to B. With a speed of 20 meter per second. Let's suppose you are having a velocity of speed. Till now we are discussing only about speed. So you are having 20 meter per second. And from B to C, you are moving with 40 meter per second. Okay. And he comes back from C to A. With a speed of 60 meter per second. Again, you came back, and from C to A, the speed that you have taken is 60 meter per second. Then the average speed of this entire journey. How we will be calculating the average speed? Average speed have simple formula. What is the simple formula of average speed? Average speed have a single formula, that is you have to write the total distance divided by the total time. So from the given values, here distances are also mentioned. Total distance, A to B, what is the distance? 200 meter. B to C, what is the distance? 400 meter. So what will be the total distance? 600. 600? No, because it is again coming back to the A. That means I can say the total distance that I will travel is 600 in one go, and in reverse time it is again 600. That means I can say it is equals to 1200. How much distance is traveled? That is equals to 1200 meter. Now what about the time? How much time is taken? कैसे लिखोगे time? Time can be written as B to C section. Time, if you have to write, time can be written as distance divided by speed. लिख लो. Distance is 200. Time is how much? 20. How much time is taken? That is 10 seconds. T2. How much distance is there? 400 divided by the velocity, that is 40. Again, how much time is taken? That is again 10 seconds. Final section. T3. How much distance is there? That is equals to 600. How much time speed with which you are traveling? that is 60. That means again it will be T3 is also 10 seconds. That means total time I can say the time taken for our motion is equals to 30 seconds. Cancel kar lo. What is the answer that we will be getting? That will be having 40 meter per second, which is the velocity. It is the average velocity. That means if I have to conclude this complete motion, I will be saying that at an average of 40 meter per second, you was traveling with the vehicle. Is it clear? Now different values can be given. Yeah, sometime they will give you time easily. You can calculate the relations. There is nothing special. So finally, the answer will be coming as 40. Clear? Easy. Now come to velocity at the same time or kind of thing. Yeah, the whatever you have decided dictated for speed, same thing will be coming for velocity as well. Just wait a minute. See, now based on time and based on distance, again it will have different types. Average velocity, instantaneous velocity, again uniform velocity and non-uniform velocity. Again it will have the same kind of definition. I'm not going to enter into that. Only change that will be coming. Velocity is defined as the rate of change of displacement. Speed was what? Rate of change of distance. So at the rate that position is changing, it will be defined as velocity. That velocity is the vector quantity. So now you have to be careful a little bit about the vectors as well. The vector values that we'll be having, what is the direction, that those kind of things now you have to consider. In speed, it was not the matter. Okay. So let's see. Most of the things will be again common. Again, see, same kind of thing. Average speed. What is the average speed? See. If you have to calculate average speed will be total distance. Total distance you will be adding up 400, 600, 900 plus 1600. Then total time is already clear that it is 500 seconds. Just divide it, you will be having average speed. Instantaneous, if sometimes someone is asking you, just do ds by dt. Differentiate if any equation is given for the position vector. Okay, position vector with time relation will be given. So just differentiate it, you will be having your relation. Correct? Uniform speed, again you can say the same kind of things here. 0 to 100 second 400 meter, 100 to 200 again 400, 200 to 300 again 400 meter. So it is covering a uniform distance in uniform time interval. Non-uniform, 100 in 100 seconds 300, again next 100 second 500, next 100 second 800. So this kind of motion is called as non-uniform motion. Again there is a question. Let's try to tackle this question. What the question is saying. Let's see. A man travels on a straight road from his home to the bank with a uniform speed of 18 km for 10 seconds. Then travels with a uniform speed of 36 km for next 20 seconds. Here the values are mentioned from A to B and B to M. Home to bank. On 20 seconds with a velocity of 36 km per hour. On a straight road from bank to market. Bank to market. Okay, this was from home to bank and then bank to market. The average speed of the man for the whole journey. The average speed for the man in the whole journey. I will be calculating simply. So how I will be writing the average velocity? See, from home to bank, how I will be writing the average velocity you have to write. Correct? Average speed. If you have to write, just take the total distance. Take the total distance divided by total time. जो भी दे रखा है उस हिसाब से कैलकुलेट कर लो. Total time, this time I can easily say that it is already given. This is 10 seconds, this is 20 seconds. That means in denominator it is, of course, it is going to be 30 seconds. अब बचा क्या? Distance calculate करना है. Can't you calculate the distance? अरे हाँ या ना? Firstly, for first step, you have to convert this better because here it is second and here it is kilometer per hour. So convert it into meter per second by multiplying it by 5 by 18. That means it will be 5 meter per second and here it will be 10 meter per second. So calculate the distance now. Distance, when you will be calculating, what will be the distance for this section home to bank? When you will be solving this now in variables, you will have the formulas also. So what kind of scenarios, what kind of formulas that you will be having. So here distance, how much you can say, speed into velocity. Here it will be 5 into 2, 5 into 10, sorry, 5 into 10, that will be the distance. That means it will be 50 plus of second portion. Here what you can say, velocity is 10, time is 20. That means it will be again, it will be 200. Here it will be 200. That means answer will be how much? 250 divided by 30, 25 by 3 meter per second. Now it's you have to convert into kilometer per hour. 18 by 5, I guess the answer will be 6 25. I guess the answer, if calculations are correct, it will be 30 kilometer per hour. So it doesn't matter. It doesn't matter that what kind of values you are given. Just your net formula. Just stick to that. That total distance covered by total time. Easily you will be having your final results. Correct. Correct. I got my answer as 30 kilometer per hour. 30 will be the final answer. Is it clear? Next one. Next question. Try to solve it. Try to solve it. What is the next question? A particle moves along a straight line path. It covers 1/3 of the total distance with a speed. 1/3 of the total distance is covered by 10 meter per second. Next 1/3 is covered with 20 meter per second, and the remaining portion is covered with 60 meter per second. When find the average speed, you have to calculate the average speed. Again, you will be doing what? Total distance divided by total time. Again, write what total distance. You can take x by 3, x by 3, x by 3. That means total distance is x divided by the total time. Total time will be what? If you have to calculate t1, how will be calculating distance? That is x by 3 divided by 10. Again here x by 3 divided by 20. Again here x by 3 divided by 60. Put all the values, you will be easily having your answer. Solve it by yourself. Okay, this is the homework that I am giving for you. Finally, the answer should be coming as 18 meter per second. Finally, cross check the answer. It will be coming as 18 meter per second. Clear? Now let's see this question. What the question is saying. This is a good one. Position of a particle changes with time. This time a relation is given of position with time. That is given equals to x is equals to 2t square plus of 3t plus of 4. Okay. This is a relation that is given. Find the magnitude of the following. You have to calculate velocity at t is equal to 5 seconds. First part. That means I can say it is asking me for specific time. That means what kind of velocity it is asking me for? It is asking me for instantaneous velocity. And I have told you that how to calculate instantaneous velocity. Just differentiate it. Position vector you have. That means you have to calculate ds by dt. That is what? The instantaneous velocity. That will be equals to differentiation also, if you know, it will be 4t plus of 3. 4t plus of 3. Now put t is equals to 5 here. When you are putting t is equals to 5 here, it will be 20 plus 3. That will be equals to 23 meter per second. Here it will be at the moment at t is equals to 5 seconds. What will be the speed that with which it will be moving? That is equals to 23 meter per second. Calculations are fine. Now the average velocity in 5 seconds. What is the average velocity in 5 seconds? First 5 seconds. I'll be calculating the average velocity from here. You will be writing what is the total distance. Of course, you have to write the total distance. So calculate firstly what is the position at t is equals to 5 minus of position at t is equals to 0. Can you say when you are subtracting, you will be having the net change in position divided by the total time. Total time is nothing but 5. Put t is equals to 5 here. T is equals to 5. When you are putting, what is the value that is coming? 5 into 5, 25, 50. 50 plus here put 5, 15. That will be 75, 79. I guess the answer will be coming. Check it again. Put 5. Here it will become 2 times of 25. That means 50 plus 15 plus of 4. That means 69. Sorry, 69 will be the result. Minus t is equals to 0. That means 4 divided by 5. Here it will become 65 divided by 5. 65 divided by 5 is nothing but 13 meter per second. The answer will be coming. The average speed will be coming. That is equals to 13 meter per second. Let's cross check it if the calculations are correct. 23 and 13. Correct. Absolute correct. Is it clear? And if still any doubt, then please ask me in the comment section. Comment section is open only for you. Is it clear? Correct. Now let's move to the next parameter, that is acceleration. That is what? Acceleration. From here, life will be changing a little bit. How? Let's understand that. Again, it will have a lot of varieties. Acceleration is clear, na? The rate of change of velocity is defined as acceleration. At what rate velocity is changing, that is what defined as acceleration. That means this time what I'll be saying, dv by dt is going to give me what? Instantaneous acceleration. See, average acceleration, I'll be calculating total net change in velocity divided by the total time. That will be defined as average acceleration. If you have to calculate instantaneous acceleration, that means what I can say, instantaneous will be talked about that specific time. That will be talked about that specific time. I'll be calculating instantaneous. Just differentiate the equation. You'll be having your instantaneous value, rate of change of velocity with respect to time, it will be defined as instantaneous. Just differentiation of the equation will be required. Uniform acceleration, magnitude and direction of acceleration does not change with time. With respect with the uniform acceleration means what? Let's suppose in positive direction in x-axis there is 2 meter per second square, and if it is constant, it is not changing with time, it is constantly moving with 2 meter per second square, that is defined as uniform acceleration. What is non-uniform acceleration? Non-uniform acceleration means what? Let's suppose for first 5 seconds it is 2 meter per second, then again it is increased with 5 meter per second, then it is decreased to 1 meter per second square. So this way, if it is keep changing with time, then it is defined as what? Non-uniform acceleration. Is it clear? Wait for a minute. I am just coming. Okay. Just wait for a minute. Hello, I'm back. What we were studying about acceleration. If I have to properly write, I will again. The orientations have been, I guess, disturbed a little bit. Voice is clear now? Once tell me. Voice is completely clear. See, the average acceleration that you are having here, you will be writing what? Let's suppose from t1 time to t2 time you are taking. So just for calculating average, you will be taking that. What is the value at t is equals to t2 minus what is the velocity at time t1 divided by t2 minus t1. Correct? This will be what? Average velocity. And for in general any kind of average, if you want to take, that is also a different formula. What will be that formula? Let's suppose any equation f of x is given, y is equals to some f of x, any general equation. I'm not talking about all the averages that you have. For any average, if you want to calculate the average of y, how will be calculating? Integration of f of x dx divided by integration of dx. This is the in general formula for any kind of average. That is valid in all the topics. Okay. Let's suppose if you want to calculate the instantaneous, if you want to calculate, just simply differentiate the velocity equation with time. That will be called as instantaneous acceleration. Correct? So let's see what kind of questions can become. Here it is again the same relation is given to you. If it is given, velocity is given as a function of time, how you can find acceleration? Acceleration can be easily found by just simply dividing it by dv by dt. Further, how you can write acceleration, it is equals to dv by dt. Correct? Let's suppose if you want to relate its position, how you can relate? Put as it is, velocity is what? It is equals to dx by dt. And if you know this relation in the basic mathematics you studied, this is nothing but double differentiation. That means it is what? d2x divided by dt square. d2x divided by dt square. Correct? Now, if it is given as a function of position, then this formula is not valid. This is the differentiation with respect to time. If it is the function that is given with respect to position, how you can find acceleration is equals to what? Acceleration is equals to, here, these are the two relations that you have to remember. A is equals to dv by dt and a is equals to d2x by dt squared. These are the two important relations from there for acceleration. Acceleration is simply what? Dv by dt. Acceleration is simply what? Dv by dt. Now multiply dx and divide also dx. Due to that, what will happen? Understand here. dv and by dx will remain in it as it is, and here multiply dt. What is dx by dt? Dx by dt is nothing but velocity. So this relation of acceleration with respect to position will be what? V dv by dx. V dv by dx. This is also one important relation that you should always remember. This can also be common to use when the positions are given. When the positions are given, then you can use this relation. It will be helpful for you. Let's suppose here it is a question, and let's try to tackle this question. See what is the question. Question is x is equals to t cube minus of 2t square plus of 5t plus of 10. This much of long equation is given. Simply x relation with time it is given. Correct? X relation with time. You have to calculate what will be the magnitude of acceleration at t is equals to 5. You have to calculate what is the magnitude at t is equals to 5. And second one, magnitude of average acceleration from t is equals to 0 to 5. So firstly, you have to calculate the instantaneous acceleration at t is equals to 5 and then the average acceleration. For instantaneous things, what I've told you, if it is a relation of position with time, it is what? d2x divided by dt square. d2x divided by dt square. That means I can say differentiate this equation two times. First time when you will be differentiating, you will be having the velocity. Check what is the velocity that you will be having. 3t square, differentiation of minus 2t square, it will be minus of 4t plus of 5. That's it. Correct? Now, if you have to find acceleration, acceleration is equals to dv by dt. That means what you will be doing? Again differentiating it 6t minus of 4. And at what time you need to calculate the acceleration? At t is equals to 5. That means put t is equals to 5. That means it will become 30 minus of 4. That is equals to 26 meter per second square. This is the first answer. Now, what you want to calculate the average acceleration. Average acceleration, I have told you what is the formula. Check velocity at t is equals to 5 minus velocity at t is equals to 0. Divide with the total time, that is equals to 5. Check. This is the velocity equation that you will be having. Now put the values here. Put t is equals to 5. T is equals to 5 when you are putting, it will be coming as what? 3 into 25 minus of 4 into 5 plus of 5 minus. Now put 0. When you are putting 0, it will be only 5 divided by 5. This 5 will simply get cancelled, and here it will be 75 minus of 20 divided by 5. That means it will become 55 by 5. That means answer will be coming how much? 11 meter per second square. Once cross check the calculation, I think that this answer will be correct. 75 minus 20 divided by 5, it will be equals to 11 meter per second square. Clear? 6 meter per second square, and second one will be 11 meter per second square. That will be the average one. Correct? Is it clear? Any doubt? How to calculate average, how to calculate instantaneous, these kind of things. Good. Now retardation. Retardation is what? Retardation is slowing down the motion. Okay, retardation is slowing down the motion. When it will be happening, let's suppose you are moving in the positive x direction. Assume that in your brain that you are moving in positive x direction and constantly, and acceleration is in opposite direction. If you understand SHM properly now, here or there also we see retardation. Retardation will be happening what? Whenever velocity and acceleration are in opposite direction, it will cause retardation, and it is represented by negative sign. It is represented by what? Negative sign. Whenever velocity and acceleration same direction, speed will increase. That means it is acceleration. Whenever velocity and acceleration in opposite direction, what will be happening? That is retardation. Always speed and velocity will be decreasing, and after covering some distance, finally it will become 0, and then it will take a U-turn. So retardation always gives you the condition of U-turn also. U-turn questions are sometimes becomes very important. Okay, in good question, if I will say, not the only formula based question, but in good conceptual questions, U-turn questions will be there. from retardation concept only. Correct. Key points about acceleration: when a particle is moving its uniform velocity, its acceleration must be zero. If anywhere it is mentioned that it is moving with uniform velocity, that means acceleration, it is indirectly given that acceleration is zero, because if there is any acceleration, it is going to change the velocity. When particle moves with constant speed, the acceleration may or may not be zero. Constant speed, if it is given, then it can be zero, it cannot be zero. When particle moves with constant speed in a straight path, acceleration must be zero. In a circular path, acceleration is always there. You know that whenever a particle is moving in circular motion, it always required a centripetal force, and if there is a centripetal force always required, that means of course it will be having some acceleration. Without acceleration, how you can get the centripetal force? Correct. Now here is this slide is very important, that is going to summarize till now what we have understood. You need to jump. Okay, if position versus time is given, how you can reach to acceleration? If acceleration is given, how you can reach to velocity? If velocity is given, how you can reach to position? All these relations you should be so clear in your mind that you can calculate just in a fraction of seconds. Let's summarize this thing. How it will be there. Let's suppose you have displacement. And you want to move to velocity. From displacement you want to move to velocity. How will you be moving? If you want to go from displacement to velocity, you can do dx by dt, differentiating it with respect to time. Differentiating it with respect to time is going to give you what? Velocity. Now let's suppose you are at velocity, you want to calculate acceleration. How you will be calculating? Just do what? dv by dt. Differentiate the velocity, you will be reaching to acceleration. One more thing. Let's suppose you are standing at position and you want to calculate acceleration. Either you can go one by one, that is the only way, but you can also write a direct relation is there, that is the double differentiation of acceleration. Sorry, position. That means d2x by dt square, double differentiation of position is also going to give you what? Acceleration. Correct. Now let's suppose you want to come back. You want to come from velocity is given, velocity equation is given, and you want to calculate position. How this is possible? Okay, how this is possible? Now there will be the concept of area under the curve. Beta, two things, any curve, anyways, when we will be coming to the graphical questions, I will be telling you two things. Always ask yourself in any kind of curve, what is the slope of this graph is going to give me, and what is the area under the curve of this graph is going to give me. Okay, in any general curve, y versus x curve, what is the slope? Slope is what? dy by dx. That means y by x. Always check what is at y, what is at x. Correct. And area under the curve, if you remember, if you have studied basic mathematics, you know, and if you don't know, please go and open your notes and again check it. Area under the curve is represented as y into dx. It is what? Y into dx. Now see here. Here let's suppose you are standing at a velocity. And let's suppose some vt curve is given to you. Any random curve is given. Okay. And you want to come to displacement. How you'll be coming? Just calculate area under the curve. Area under the curve in generally what I've told you, that integration of y dx. But tell me what is that y-axis here? Y-axis it is velocity, and at x-axis it is time, that is dt. एक बार चेक करना इसका dimension क्या आ रहा है, because we know, just we have understood the dimension analysis. We know that velocity is lt minus 1 and time is t. That means t minus 1 and t will be simply cancel out. That means the final result that will be left here will be L. That is the unit of position. That means the integration of v dt will be taking me backwards. Velocity to position, if you want to come, please remember this. When you are integrating velocity with v dt, you will be coming to position. Same way, let's suppose you are having an acceleration. Mostly the curves will be given. From acceleration to velocity, if you want to reach, how will be reaching? From here, direct also relation see na. A is equals to dv by dt. Correct. Now you want to reach to velocity. How will be reaching to velocity? A dt, and integrate both the sides. I can say you are reaching from velocity to acceleration. You know that differentiation and integrations are reverse process. So this is applicable here also. Simply. Correct. This slide is very important. As much as star mark you want to do, make it. And please remember, this should be in your brain. It should be settled down in your brain, that in the fraction of second you should be understanding how to do this switchings. Okay. Now let's come to the next portion, that is equations of motion. How to tackle the questions of equations of motion. What are the equations of motion? I hope that all of you would be understanding. We are not entering into the derivation. Equations of motion, one is x is, if I'll ask you first equation of motion, v is equals to u plus at. V is what? Final velocity. U is what? Initial velocity. A is what? Acceleration. And T is what? Time. Second equation of motion, S is equal to ut plus half at square. S is representing the displacement. I hope that this will be clear. Third equation of motion, V square minus U square is equals to 2as. That is the third equation of motion. Using three equations of motion and along with the sign conventions, proper sign conventions should be mentioned. Along with these three things, you can solve any kind of questions of acceleration. Any kind of questions of kinematics you can solve using these three equations. Okay. So let's understand and let's learn how to apply that. I will be telling. Always for these kind of questions, it is very important to write the given value. What is the given value? It is given present. Just firstly write all those values. Check here. A particle moves in a straight line with a constant acceleration. A constant acceleration is there. It changes with a velocity from 10 meter per second to 20 meter per second. It changes from velocity 10 meter per second to 20 meter per second. That means final velocity is 20 meter per second. While passing through a distance of 100 meter, find the value of acceleration. See, what are the values that are given? Straight line with a constant acceleration A. Changes with U is given as 10 meter per second. Final velocity is given as 20 meter per second. Distance S is given as 100 meter. And they are asking you for what is the acceleration. Beta batao, what are the relation that you know between all these four values? Try to find a relation. What is a relation? Can you say you know a single relation where these all these four values are related, where V square minus U square is equals to 2as? Isn't it? Correct. Now just solve it. V square, that means 400 minus U square, that is 100, is equals to 2 times of acceleration that you have to calculate, and the position, that is equals to 100. Here how much it will become? It will become 300 is equals to 200 into acceleration. Cancel. Acceleration will be equals to, I guess, 3 by 2 meter per second. Clear? Is it clear? समझ आया? Any doubt? Simply I have applied the equations of motion. I hope that this will be clear. 3 by 2, that means 1.5 meter per second square. Now the another very important formula that is there is displacement in nth second. A lot of time questions will be asked that tell me what was the displacement in the 5th second, in the 4th second, in the 3rd second. What is the meaning? That means what is the displacement between, if the question is asking you displacement in the 5th second. In the 5th second, simply the question is asking you do S net displacement in 5 seconds minus net displacement in 4 seconds. That will give you the net displacement in 5th second. Correct? So we have a direct formula for that. What is that direct formula? Here in nth second, if you want to calculate displacement in nth second, if you want to calculate, just simply do U plus A by 2 into 2n minus 1 into 2n minus 1. This is the simple formula that you will be using for the displacement in nth second. What are the terms? It will be clear. U is initial velocity, A is acceleration, and n is what? N is the time in which second you are asking, that is the time that is given here. Okay. Now if the cases are under motion under gravity, what are the difference that will be coming? Gravity is what? It is a simple kind of acceleration. So if it is a case of gravity, simply gravity is always acting in downward direction. Acceleration, that is equals to gravity, is always acting in downward direction. And conventionally, I've told you now that two things will be important. Formulas you will be easily applied, but the next thing that will be important is what? The sign conventions, that how sign conventions you are taking. So when you are taking it in downward direction, it will become negative. We consider the downward direction for solving purpose. We take conventionally it as negative. So always the value, that is, let's suppose formula is V is equals to U plus AT. This formula will become V is equals to U minus of GT. At the place of acceleration, it will be G and it will be taken as negative. Here also, if you will notice, S is equals to UT minus of half GT square. Then V square is equals to U square minus of 2GS. So everywhere you will be just making a small change, that will be gravity will be coming into scene. Correct? Now let's suppose the first concept, let's suppose you are throwing a ball from the ground. Let's suppose you are throwing a ball. What will be the time of flight? Here it is little bit cluttered. Orientations have been disturbed a little bit. Let's suppose you are throwing a ball from the ground level and you want to calculate what is time of flight. Time of flight is, let's suppose I am throwing any particle from it, it is going in upside direction. What will be happening? This going upside, it is called as time of ascent, and when it is reaching its maximum height, then again it will be coming down. The time to come down from the maximum height is called as time of descent, and these two are identical kind of scenarios, and that's why we say that time of ascent is equal to time of the descent. And the complete time to taken, that means the complete time to taken from this point to again reaching the maximum, again reaching to the same place, this complete time taken is called as time of flight. In projectile motion, this same kind of things that we discussed. And what is the concept that we always used in this kind of scenarios? If I have to tell you, simply tell me what it is, going from the ground and again it is reaching back at the ground only, correct? So tell me, what is the displacement in y direction? What is the relation that we know? S is equals to ut plus half at square. Half at square, correct? So if I will ask you, tell me, what is the net displacement in y direction? If I will ask you, can you say it is nothing but equals to 0? Let's suppose initial velocity is some u into t, and t is also, let's suppose, time of flight. And acceleration, how I will be writing? Minus of half into g into time of flight square, and here it is equals to 0. Now just solve it. What will be getting from here? It will be half g time of flight. Time of flight will be taken common and it will be cancelled. It is equals to u. That means time of flight is equals to 2u by g. 2u by g. This will be the formula. And how to find that formula, that also I have told you. So in good questions where the direct formula, let's suppose if it is not applicable, you should be very clear how to derive the things also, because in good questions always the derivations is going to help you. These kind of things you should be understanding. Clear? Let's suppose the question is asking you for maximum height. What is maximum height? Maximum height, let's suppose you are given some velocity from the ground level and it will achieve its maximum, and then again it will be coming down. So what is the condition that we create for maximum height? Tell me, what is the condition that we create? Batao, anyone? Anyone knows what is the condition for maximum height? How we create maximum height? Comment. Let's see. The condition for maximum height is, should I tell? No one? Okay, fine. I will tell. The condition for maximum height is, whenever it achieve its maximum height, initially you are given some velocity, acceleration is in downward direction, correct? Velocity upward direction, acceleration downward direction. That means what will be this kind of, it will working as a retardation. That means it will be decreasing, velocity is decreasing, and at maximum height, finally velocity will become 0. Finally velocity will become 0. So just that property we have to use this relation, v square minus u square is equals to 2as, is equals to 2as. So that how you'll be writing, final velocity is equals to 0, minus of u square is equals to 2 times of acceleration is minus of g into s. S is what? The displacement, or you can also write it as h max, maximum height. Now this minus will be get cancelled, and h max will be written as u square divided by 2g. What is the formula for maximum height? It is equals to u square divided by 2g. Is it clear for maximum height? Correct. Now see, there is a basic question. Just solve it using the formulas. Values are given. Chalo, dekh lete hain. A ball is projected vertically upwards with a speed of 50 meters per second. Initial velocity is given. The maximum height that you will be achieving. What is the formula for maximum height, students? H max is equals to u square divided by 2g. U square is what? 50 into 50 divided by 2 times of 10. G, if it is nothing mentioned, we will be taking it as 10. That means it will become 25 into 5, 125. Correct? 125 meter. 125 meter. Second one. Secondly, what you have to calculate? Time of flight. How you will be writing? It is equals to 2u by g. That means 2 times of u. How much initial velocity? 50 divided by 10. How much time of flight will be there? It will be 10 seconds. First answer 125 meters. Second answer 10 seconds. Is it clear? Just simply you have to apply the formula, nothing else. and the derivation already we have seen. If you want to go from the conventional method, you can go from the conventional method, no problem into that. Correct? Now come to the graphical portion. We'll understand the basic graphs that will be present there. Okay, we'll understand how to make the graphs, what is the meaning, what are the interpretations that we can have from the graphs, and this will be the last portion of the kinematics. Okay, let's start. First one is position time graph. Position versus time graph. It is given, and it is given for what? Let's suppose you are having a uniform motion. Uniform motion means what? Uniform velocity. Let's suppose having, if you are having a uniform velocity, that means acceleration is what? 0. Acceleration is what? 0. That means if I will ask you position versus time, it is a case for acceleration is equals to 0. Acceleration is equals to 0. If acceleration is equals to 0, tell me what is the relation between position and time? I can say distance is equals to speed into time. That is a basic thing that we understand. Correct? And x versus t, that means what I can say? This position is at y-axis, this time is at x-axis. Correct? So I can say that this is a line that is equals to y is equals to mx, sort of straight line that is passing from the origin. Correct? Y is equals to mx. So I have got this kind of line. What is y is equals to mx? And what is the slope? M is going to give me what? Speed or the velocity. This y is going to give this slope is going to give me the velocity. These things should be, you should be able to interpret the meanings and how, what is the reason for all those curves that you are having. Velocity, can you say velocity is constant because acceleration is 0, so simply it will be having a straight line. About acceleration versus time, it will be 0 because acceleration is 0, so simply draw a straight line that is at x-axis. Is it clear? When body is at rest initially, when body is at rest for different conditions, it is given. Initially, object is at point x is equals to 4. Okay, and it is also for uniform motion. Here you see position versus time. Initial velocity is 0, and final velocity is also 0. Acceleration is as well 0. That means position is not changing. That means it will be a simple straight line that will be parallel to the x-axis because position is not changing. That's why a simple straight line. Second case, object is starting from origin. And velocity is constant. Acceleration is 0. Velocity is given constant. That means acceleration is 0. That means already we have discussed that it will be a straight line. Y is equals to mx, sort of, that will be passing from the origin. Second case, if velocity is acceleration is still 0 and velocity is negative. If velocity is negative and here anything is else mentioned, object is starting from the position x is equal to 5. It is mentioned that it is starting from x is equal to 5. That means what kind of curve you will have? See, here initially you are as position x is equal to 5. Correct? Plus, but your velocity is in negative direction. Velocity is equals to negative. That means what do you understand? That it is in negative direction. That means it will have a negative slope. That means the slope will be like this. The straight line will be like this. You will be having that y is equals to mx. And this slope is negative. That means what kind of line that you can draw? Simple maths, simple graph that you should be knowing how to plot. Clear? All these graphs you can create by yourself. See, the accelerated motion is there. Acceleration is not equal to 0, and position versus time, again curve you have to create. Position versus time. What kind of curve you'll have? Write the relation of position versus time when acceleration is present. We know a single relation, s is equals to ut plus half at square. S is equal to ut plus half at square. So what kind of relation I have? This is at y, this is at x plus half into ax square. So can I say y is proportional to x square? That means can I say it is a quadratic equation? If it is a quadratic equation, that means I can say simply that it is going to be a parabola. Quadratic equation gives me what? A parabola. You will be having a slope at all the places that is going to, yes, if you are having a slope of this position versus time, it is going to give you what? Dx by dt. Dx by dt is going to give you what? Velocity. Correct? So the slope of these curve is going to give you velocity, and it will be a parabola opening upwards. Reason is acceleration is equals to positive. Correct? Here you will be saying that acceleration will be negative. Somewhere it will be mentioned both v1 and v2 are negative. Velocities are negative. That means acceleration as well, it is given as negative. That means you will be having, again you will be having the same relation, just a small change will be there. Here you will be putting a negative sign. That means you can say y is proportional to minus of x square. That means parabola facing downwards. Okay, quadratic equation, basic quadratic equation, if you know, you can easily plot all these curves. Clear? Now come to the next section, that is area under curve. Area under curve, anyways, we have already discussed, but some important things are there that I will tell you. It is given as velocity versus time. What I've told you, that in general, area under any curve is written as in general y dx integration. From now positions will be different from x1 to x2. Now it depends, correct? Let's suppose you have having any in general curve from time t1 to t2. From time t1 to t2, you want to check, okay, tell me what is the area under the curve is going to give me. So what we'll be doing, simply put at y-axis what is present, velocity, at x-axis what is present, time. So I will writing v into dt. Now check dimensionally. When you will checking dimensionally, just now I have told you that it is going to come as length. That means the net area under this curve, if I will integrate it from t1 to t2, it is going to give me the displacement. From time t1 to t2, how much I have displaced, it is the area under this curve is going to give me. Is it clear? Next one, let's suppose you have, this is positive section, then sometime you will be having negative velocity, again you will having a positive velocity. So let's suppose again this is going to give you the position, but there can be case that it is either displacement or either distance. Okay, both things are possible, because we have just only for the length dimension. It have not mentioned that it is displacement or distance. So here you see, if the question is asking you displacement, that means what you will be doing, displacement can be negative also. So this you will be writing it as plus of a1. For here it will be writing it as minus of a1, and for this area 3 again you will be writing plus of a3. This way you will be writing the displacement. But for distance can never be negative. That means simply you will be doing a1 plus a2 plus of a3. For what? For distance, for calculating distance. That will be the slight difference that will be coming due to distance and displacement. Is this clear? That is also what we have discussed. Correct? See, simply here it is a very basic question. Check what is the question. The velocity time graph is given, moving object is given, displacement of the object in 10 seconds. Here I can say this both these areas are completely identical. So it is, let's suppose it is going to give me, or if you want to calculate कर लो यार. पहले तो ये clear है ना, that area under the curve is going to give you the either distance or either displacement. So let's calculate area A1. Area A1, if I have to calculate, I will be writing half into base into height plus area, this is area 1, area A2 half into again base, that is 5, into height, that is 5. That will be again, that is 25 by 2, and this is also 25 by 2. Correct? Now if you have to calculate displacement will be what? A1 minus A2. A1 minus A2. And can you say both, if areas are equal, net displacement is equals to, will be coming as 0. That means the point from where you have started, again after covering some distance, you have again come back to the same position. That means I can say there is no net change in position. Again you are standing on the same point. इसे गाना याद आता है, खड़ा हूँ आज भी वहीं, है ना? So खड़ा हूँ आज भी वहीं, that means displacement is 0. Simple. मैं बहुत बुरा हूँ गाने में यार. Distance, total distance traveled. Distance तो simple है यार. Distance if you have to calculate, simply do A1 plus A2. If you are doing A1 plus A2, just add up both these areas. That means 25 by 2, 25 by 2. That means net distance that is traveled is 25. Displacement is equals to 0. Distance will be equals to 25. Clear? समझ आ रहा है? Graphical बहुत बच्चे डरते हैं यार due to from the graphs, but it is not that much of the thing. Okay. Here simply see, if acceleration is equal to 0, simple this kind of line. Acceleration is equal to positive, that means, and constant acceleration, that means acceleration will be a straight line positive. Acceleration is negative, that means again a straight line, thus representing the negative sign. क्या ही है इसमें? If you want to represent this acceleration is equals to a, that is constant, how will be representing it in velocity versus time graph? What will be the relation that we will be putting in velocity versus time? If you are taking the slope, everything will be coming only from the two things, either from slope, either from the area under the curve. Check out velocity versus time graph ka slope. If you are writing in general, slope is what? Dy by dx. Now check, what is that y-axis? It is velocity. What is that x-axis? It is time. That means it is going to give you what? Dv by dt. Slope is going to give you dv by dt, and it is nothing but equals to acceleration. And here it is written that acceleration is equals to constant. If acceleration is equals to constant, that means this will be a straight line. This will be a straight line. And why this intercept is there? If you want to understand that, see what is the relation between all these three quantities: acceleration, velocity, and time. I know that there is a relation v is equals to u plus at, and I can say v is what at y-axis, u is some intercept, plus of acceleration, that is equals to slope, that means m, and this time is equals to x, that means y is equals to mx plus c, and this c, if it is positive, it will be having this kind of curve. This is what the intercept, initial velocity. If initial velocity is 0, this line will be passing from here. सब कुछ कर लोगे यार, every single thing you can interpret from there. Okay, next thing, let's suppose you are having position versus time. Already we have discussed position versus time, already we have discussed. S is equal to ut plus half it square curve is going to give you this kind of curve, parabolic curve. Clear? So just ask yourself a proper question. Ask yourself a proper question. Okay, that's it. Now let's discuss a little bit about reference and relative velocity. Reference and relative velocity. I love this section. It is very, very interesting. See, what is the case here? Person A is standing, person B is standing, and person C not standing. B and C are moving with the same velocity as V. Okay. Now, this is a little bit different, disturbed. With respect to A, both, let's suppose you are asking, let's make our own question. With respect to A, what we will be observing about B and C, what they are doing with respect to A. With respect to, whenever I am saying with respect to, that means you will assume that you are that observer. Let's suppose you are standing at this position and this position is A. If I'll ask you, tell me A, what about you understand about the behavior of B and C? So what will be saying, sir, B and C are moving in forward direction away from me in a velocity that is equals to V. Correct? Now I'll say, you student, you are the observer, you are let's suppose B, you are let's suppose B. So now if I'll ask you, tell me the behavior of A and C. Now if I will ask you the behavior of A and C, what you will be telling me? So if you are B, C is at rest because both of them are moving with the same velocity. That means B and C are moving with the same velocity. That means you will say what? If you are B, sir, C is at rest, and this person A is moving in the negative direction with a velocity minus of V. You will be feeling that you are at rest. For example, yeah, let's suppose you are just sitting in a bus, okay, and a person is standing on the road. Silently he is standing. What you will feel? That you are at rest, you are not doing anything, you are at rest, simply sitting. What will be feeling? And let's suppose a friend is sitting with you. What will be feeling? That me and my friend are both at rest, but that person is moving in backward direction with a velocity v. Exactly the same scenario. And for the person, if I will say, person will be feeling that I am at rest. These two friends are going up forward direction with a velocity v. This is a simple case. That is what at the starting of this chapter I have tried to tell you. This complete thing is a reference kind of scenarios. Everything goes in a reference. Reference is very important with respect to whom you are watching the motion. Is it clear? Let's suppose this question, very interesting question. Just from common sense, just tell me. After that, we will be watching that how to solve this kind of question. That is a different thing. A train is moving with a 54 km per hour. A train is moving in forward direction with 54 km per hour. A monkey runs on the roof of the train opposite to the direction with a speed of 10 km. एक बंदर है जो कि move कर रहा है in opposite direction with 10 km per hour. Okay, वैसे तो मर जाएगा अगर if it is an electric train. Still, it is moving with a negative direction of 10 km per hour. With respect to the train, find the velocity of monkey as seen from the ground. As seen from the ground, let's assume yourself that you are standing on the ground. Okay, you are standing on the ground and you are watching this motion. What you will be feeling that what is the motion of the, what is the speed of the monkey? From the common sense, just try to imagine this, just try to feel it. What kind of motion you will assume? That train is moving, that means monkey is also on that it is moving net in 54 km per hour in forward direction. But it also have its own speed that is making it move in the negative direction with 10 km per hour. That means what will be the effective velocity you will be feeling? Can you calculate without any physics, nothing, just a normal observation? Can you do it? Understand. In physical terms, how to solve it? Understand that. What I have told you, what you have to calculate, what is the velocity of monkey with respect to train? What is the velocity of monkey with respect to train? That is already given, that is equals to minus of 10 km per hour. I will take it this velocity as minus. This is the velocity given. A monkey runs on the roof of the train in opposite to the direction with a speed of 10 km/h with respect to the train. That means velocity of monkey with respect to train. This is a representation. I hope that this is basics to aata hoga. This is representation for this is what is the meaning of this line that I have written. Velocity of monkey with respect to train. That is equals to minus of 10, and it can be written as velocity of monkey with respect to ground minus velocity of train with respect to ground. With respect to ground. So how I'll be writing, it will be minus of 10 is equals to velocity of monkey with respect to ground. That is what I have to calculate, and this velocity of train with respect to ground is already given, that is equals to plus of 54. Now what will happening, this velocity of monkey with respect to ground will be equals to, take it there in another direction, that means another side, it will be 54 minus 10, that is equals to 44 km/h with positive direction. That means if a person is standing on the ground, he will be feeling that the net velocity of the monkey, he is moving in the positive x direction with a velocity of 44 km/h. Is it clear? Is it clear? Very good. Very good. Okay. Wow, what a transition. So the next chapter is the laws of motion. Finally, we have covered the relative portion also. Okay, relative portion also we have covered. Now relative is a kind of section that used to come in all the chapters. Okay, so in whenever it will be coming, we'll be tackling the questions of relative motion as well. So we'll be taking laws of motion in the next lecture. Until next time, keep learning, keep growing with Tapasya. Endigu, Nama Tapasya.